Hello and welcome everyone. We have a question number of pairs. Before jumping into the problem, I want to share a backstory. In the last week, while I was preparing for the Amazon interview, I faced this question, but after spending some time, I analyzed that it requires a little bit more thinking, so I just ignored the problem. So if you are interested how my interview went, be sure to check out the video given in the I button. So today I faced this question again. So after spending some time, I am able to solve this question. So let's directly jump into the question. What it say? We have given two positive integer arrays for array 1 and array 2. We have to find the number of pairs such that x to the power of y is greater than y to the power of x, where x is an element from array 1 and y is an element from array 2. So you can solve this question by comparing every pair, so that time complexity will be n cross m, but we have to somehow optimize this. If we have a pair x to the if we have a value x to the power of y, we have to find that value. So this value must be greater than the other value, which is y to the power of x. In this case, first we have this pair, so 2 is greater than 1, then this pair, then x to the power of y, so this is greater than y to the power of x, then third is this. So if you look at this, what we can see is, if power is more, if our y value is more than x value, then our first value is greater than the second value. But this is not always the case. Let's approach this question first. So we have to find x to the power of y is greater than y to the power of x. This is true if y is greater than x. If y is greater than x, means our power, this power, y power is more. Let me give you an example. So suppose 2 suppose 2 to the power of 16 is greater than 16 to power of 2. This is much more greater than this, because y is greater than x. But this is not always the case. We have some exceptions here. So what are those exceptions? So first, let's check out with this pair. What we have to do? We have to find the value of y. The value y must be greater than value x. So instead of comparing each and every value, what we can do? We can sort the second array. So after the sorting the second array, let me write the sorted array first. So here is the sorted y array, and we have to find the value of y which is greater than x. So suppose we have x value as 2. So 3 is more, 3 is more, then all the values on the right hand side is more. All the values on the right hand side is more. This is true. So why not we can apply binary search? Here we have to apply binary search. So we apply the binary search and find out the index. So the index is this. After this value, all the values on the right hand side, including this value, is greater than the y is greater than x. So in this case, it is true. But we have some exceptions. Suppose we have to find x, x to the power of y. This is greater than y to the power of x. Let's take this value is 2 raised to power 3 is greater than 3 raised to power 2. In this case, it is 8, and in this case, it is 9. So for 2, 3 is not the case. What about 0? So let's take 0 first. So what about 0? So x is 2, x is 2, and y is 0. Y is 0. So we have a value 1 here. So 0 is correct. What about 1? So if we have 1, so in this case it is also true. What about 2? So 2 is not correct. So we can say for 2, for x has 2, 3 is not correct. So let me write with red pen. So 3 is not correct. 0, 0 correct. 0 is correct. 1 is correct. 2 is not correct. So we have to find all the values on the right hand side. So in this case, 3 is not correct. What about 4? So x is 2 and y is 4. So we have this. So it is 16, and here we have um, no. I think I missed a value. So I missed 2. So for 2, for 2 it is it is same. So 2 is also not correct. So 2 is also not correct. 2 is not correct. 3 is not correct. What about 4? So 2 raised to power 4, 4 raised to power 2, 16, and it is also 16. So 4 is also not correct. 4 is also not correct. What about 5? So here we have 5, I think it is 32. So here we have 5, it is 25. So 5 is correct, and all the values on the right hand side is correct. So I find that there is an exception here for 2, and all the values on the right hand side is satisfying this condition, is satisfy this condition. And we have to find x raised to power y is greater than y raised to power x. And next we have this 0. So for 0, for 0 we have this index. We have to find x, y, the y value is on the array, in the is on the second array. So we have to find the value which is greater than x. So this value satisfies. So let's talk about 0. If x is 0, if x is 0 and we have a value 1, and I am writing this condition. So y1 and x 0. So if we have something as 0, so it is 1, so it is 0. So for 0, 1 is not correct. So this is not correct. If we have value as 2, so this is also not correct. If this is value 3, then this is also not correct. So for x0, no value, no value will be correct. So null. I am writing not available. Value is not available. So no value. So next we have 5. What about 5? Next we have value 5. So after 5 we have these values. But here is some exception. Here is some exception. What about these values 0 and 1? Because this is some smaller values. So I have x as 5 and y as 0. Y as 0, x as 5. So is it correct? 1 is greater than 0. So this is also correct. So if we have a value, so let's suppose x. Let's suppose x. So for x, 0 is correct. What about 1? So if we have 1 here, if we have 1 here, so this is 5 or x, and this is 1. So 1 is also correct. And what about 2? So this we have here we have 2. So here it is 5 raised to power 25. It is 25. So then 2 raised to power 5. So this is not correct. Means 0 and 1 is correct, and all the value greater than x is correct. So we found that there is some exception for x also. Means 0 and 1 we have exception. So we have to find the frequency of 0 and 1. What's the frequency of 0? What's the frequency of 1? We have to count this frequency. What about 3? So x we have found that 0 is 1 is an exception. What about 3? So for 3 we have this. See, all the values is on this side, all the values on the right hand side, and including this value is greater than x. But what about 0, 1, 2, 3? So let's check out. We have x as 3 and y as 0. Y as 0 and here. So for 3, this is 1. So for 3, we have exception here. Means 0 is correct. For 3, 0 is correct. What about 1? So here 1, 1. So it is also correct. For 1, it is also correct. What about 2? For 2, 2. No, this is not correct. we have 8 here, and we 4 4 then 8. So 8 here, and here we have 9. So for 2, 2 is also correct. 0, 1 and 2. What about 3? So 3 is not correct because we have equal values. Then we have all the greater values. So all the greater values this side. So we are finding some exceptions. Then what about 1? So if we have x as 1, if we have x as 1, then this value and all the right side value is greater than, means y is greater than x, y is greater than x. So what about 0 and 1? X, we have x value as 1. So what about 0? If y is 0, if y is 0, so this is 1 and this is 0. So for 1, so for 1 we have value 0. What about 2? If x y is 2, if y is 2, actually I missed 1 because 1 is not correct, we know. So what about 2? So here it is 2 and here it is 1. So 2 is not correct, although it is greater than x, but for 1 this is not correct. What about 3? 3 is not correct. What about 4? 4 is not correct. So I found that for 1 only, for 1 only 0 is correct, and we don't have to care about all the greater values. So we have found some relation 0, 1, 2, 3, 4 and x. So we have some if else condition we have to write, and here we are interested in 0, 1, 2, 3 and 4 frequencies. So what do we need? We will make a frequency array. We will make a frequency array of 5 size. So it will store 0, 1, 2, 3 and 4 frequencies, and we iterate in the y array and count the frequency of 0, count the frequency of 0, 1 and 2. And after finding the frequency, we write some condition. For 2, we are interested in 2, 3 and 4. Uh, for 2, 2, 3 and 4 is not correct. So for 2, it will point to value 3 and 4 because 3 is greater, but we will subtract the frequency of 3, frequency of 4, and we will we have all the frequencies which is greater than 4. Uh, and we also require 0 and 1 frequency in this case because 0 and 1 frequency is correct in this case. So that's how we will do. These conditions are important. These conditions are important. So uh, while remembering this, I have to write some conditions, and I have to apply binary search, and we need to find the index. We need to find the index which is greater, whose value is greater than x. So let's code this. First we need to sort the array, and then we need to find the frequency. We are only interested in 0, 1, 2, 3 and 4 frequencies. So if value is smaller, then we increment the frequency. Then we have a variable answer. While iterating in x, so we will count all the values. So I am passing the variable y array, its size and frequency, and then add into our answer. At the end, run our answer. So we have this function, count function. In this we have a variable a value, n value and frequency. So if x is 0, so if x is 0, 0, no value is available. So I'm writing returning 0. If x is 1, the only value for the only value for which this pair will satisfy is 0. So if x is 0, we need to find the frequency of 0, and for all the other frequencies we have to find the lower bound. Count greater values. So I am applying binary search. Find the middle value. If this value is smaller or equal than x, means greater value is present on the right hand side. So I am going in the right hand side. Else either this value will be true or we have to find the lower bound. So we have to do this. middle value is also true. Then we have some range. All the values on the right hand side means n, L points to the greater value, and all the values, all the remaining values in the right hand side is also true. So that's how we will find the pairs. But we have some condition, 0 and 1, 0 and 1 we have handled it. Let's talk about 2. So for 2, it will, we have a answer which points to value 3. So 3 and all the values greater than 3 is true. But for 2, 0 and 1 is also true. For 3, 0 and this is 2 2. So for 2, 0 and 1, 0 and 1 is also true here in this case. And we have to subtract the frequency of 3 and 4. So 3 and 4 is not uh, is not will not make any pair, and answer points to 3. So that's why we have to find, we have to subtract the frequency of 3 and 4. So what about 3? If x is 3, then we have a pair 0 1 2. So 3 points to the value value 4, or then we have answer, and we need to include the frequency of 0 1 and 2. So that's how I'm including. And for x, for all the remaining values, we have to also include the frequency of 0 and 1. So for x, 0 and 1, frequency of 0 and 1 we need to include. And at the end, that's it. So let's submit this. And in between, let's talk about time and space complexity. So first we are sorting our array. So its size is n. So it will take n log n. Next we are iterating, and we have a count function. So for count function, what we are doing is we are applying binary search. So binary search time complexity is log n, and we are doing it for m times. M is the frequency of this array. So it is m log n plus n log n, m log n plus m. So we have a common here which is log n. So we will take out log n outside, and we have a time complexity. So we have reached the expected time complexity. And for space complexity, we have just this array. So this is a constant, a constant thing. So its space complexity is constant. And that's it. Thank you all for watching.